All right. This is still the fall common assessment from the school year of 17-18, 2017-2018. And it is going to be questions 11 through probably like 20-ish. Okay. At Ohio State University, about 19% of incoming freshmen are first-generation college students. If there are 10,931 incoming freshmen this fall, which proportion can be used to calculate the number of freshmen that are first-generation college students? Okay, so I know that a percent, like 19%, is out of 100. So I'm looking for a relationship where we have 19 out of 100. Oh my gosh, is it that easy? Wow. Okay, done. I'll keep explaining. There are this many total freshmen, and only part of them are first-generation college students. So we are looking also for a proportion where 10,931 is in the denominator. But check it out. That was a pretty fast one. And we can move right along. Ooh, this looks like it's a probability question. Okay, 3 dice are rolled at the same time. What is the theoretical probability? That means like the mathematical chance, not like, oh my gosh, something really weird happened, that an even number is rolled on all 3 dice. Okay, well, first of all, on a die, one single one of these, there are numbers 1, 2, 3, 4, 5, and 6. 2, 4, and 6 are the even numbers. Okay, my bad. That's why we should always have our phones off during math class. Okay, so even numbers. We got 3 even numbers on one of the die. It's going to be the same 3 even options on the other 2. But the probability of rolling an even number on, let's call this number 1, is going to be half. Half of the numbers are even. The probability of rolling it on the second one is also half, and the third one also half. When I'm calculating probabilities, I don't want to add them together. I want to multiply them. 1 times 1 times 1 is 1. 2 times 2 is 4 times 2 is 8. The probability that all 3 of these will land on even numbers, like in the picture, 6, 2, 6, even numbers, is 1 out of 8 rolls that will happen. Okay, next one. The cost of 5 pounds of oranges is $5.70. What is the constant of proportionality that relates the cost in dollars, y, to the number of pounds of oranges, x? Okay, so if 5 pounds of oranges is $5.70. Ooh, actually, I'm going to put the dollar sign up there. What is 1 pound of oranges? Divide by 5. Wait, isn't it going to be the same for every single one of them? Yes, it is. That's why we're dividing. We want to find this. Okay. 5 goes into 5 one time. Oh, look. Only one of them starts with a 1. I don't even need to finish my division. There's my answer. I could, and it would give me $1.14 for every pound of oranges, which is the constant cost no matter how many pounds of oranges you have. But it's super nice to be able to say, oh, hey, look, there's my answer just from doing the first part of my problem. Maybe it wouldn't have eliminated all the answer choices in every problem, but it's always a good thing to keep an eye out and keep looking to see, especially when you're taking a test. It's more a good test-taking strategy than a good math strategy. You could eliminate answers and find your final solution, your answer, pretty quickly there. Okay, next one. Number 14. The ingredients listed are used to create a small 4-serving batch of brownies. 4-serving batch of brownies. All this stuff, okay. I'm not really going to read it until I know what I'm looking for. How many cups of sugar and cups of butter are needed for a 24-serving batch? Not what I have here. Okay, so I don't care about cocoa powder. I don't care about flour. I don't care about vanilla or eggs. I'm just looking at these 2. Okay, this is a 4-serving batch. I want to scale up my recipe to make 24 servings. 4 times 6 is 24. So I'm going to take butter times 6, sugar times 6. Let's see, half times 6 is going to be 3. So I'm looking for 3 cups of sugar. 3 cups of sugar. Nope. 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 Oh my goodness. Really? So easy. Double check it. 6 times a fourth. Well, 1/4. 6 times. 4/4 makes a whole. 2/4 is a half. 1 whole and 1/2 cups of, oh, yep, right there. Moving on. Number 15. There are 30 homes in a nearby newly built subdivision. There are currently 3 companies that homeowners can choose from for their internet service. Company A, Company B, Company C. The remaining homes don't have internet. Okay, cool. How many homes in the subdivision have not yet chosen their internet provider? Okay, so there are 30 homes. 1/10 of them go with A. 1/10 of, remember of means multiplication, 30 is 1/10 times 30, which is 30 tenths, which is 3 holes. Okay, 3 homes have already gone with A. Company B provides internet to 40%. Okay, there are 30 homes. 10% is 3 of the homes. Times 4, because we want 40%, 12 of the homes go with Company B. Company C provides internet for 1/6 of the homes. 1/6 of means multiplication. 30. 30 divided by 6 is 5. 5 of the homes go with C. Okay, so we got 3 plus 12 is 15, plus 5 is 20. That means 10 homes haven't picked who's going to be their internet provider yet. There we go. Number 16. Yurissa has been collecting and saving all the coins she's found for the last year. Her goal is to collect enough money to pay for a new furniture set for her bedroom. The bedroom set she likes costs $229. That's going to be a lot of coins. Okay, yep, big numbers. She has 405 dimes, 138 nickels, 227 quarters, and 1,001 pennies. How much more money does she need to save before she can purchase? Okay, wow. Alrighty, whew. Good thing some of those other ones took us a short amount of time, because this one might take some work. First of all, just some knowledge I need. A dime is 10 cents. A nickel is 50 cents, 5 cents. A quarter is 1/4, a quarter of a dollar, 25 cents. And a penny is 1 cent. Okay. So, she has, oh gosh, let's start with the pennies. 1,001 pennies. Well, I know that it takes 100 pennies to make a dollar. So let's start by dividing by 100. And let's see where we get. 1. And nothing. And decimal point. And nothing. And another 0. And it goes in 1 time. Oh, hey, look at that. There is a very clear relationship. We got the same digits, just dividing by 1, 2, dividing by 100. Okay, so she has $10.01 in pennies. How about in quarters? Okay, let's see. Well, 227 quarters. We could also do it this way. Times 25 cents is going to be what? Oh, all right. 5 times 7 is 35. 10 plus 3 is 13. 10 plus 1 is 11. Place value. 2 times 4 is 17. 2 times 4 is 4. Plus 1 is 5. 2 times 2 is 4. Add them all up. You got 5, 7, 6, 5. Don't forget 2 decimal places. Whoop, whoop. Okay, so she has $56.75 in quarters. Not too bad. That's a lot of coins, but a lot of money too. Okay, nickels. We got our quarters, we got our pennies. Let's move backwards up the list to nickels. 138. Let's do the same strategy times 5 cents is going to be 40. I'm just going to ignore the decimal point and the 0 there because I can add my decimal back in. 15 plus 4 is 19. 5, 6. Okay. 1, 2 place values. 1, 2. All right, not as much. She's got $6.90 in nickels. Notice how I'm writing them over here and I'm still stacking my decimal points just so I don't have to rewrite them all again when I add them up. Last one. Dimes. And I'm running out of space. We got 405 dimes. Each dime is worth 1/10 of a dollar. That's going to give me, it's like multiplying by 1 with 1/10 in there. We got $40.50 because I can add a 0 in dimes. Okay. Whew, that was a lot of work. I filled the page. I'm not even done yet. 0 plus 1 plus 5 plus 0 is 6. This one ends in a 6. This one ends in a 6. No, no. Oh, but don't let that fool you. Because this is how much money she has. We want to know how much more she needs to save. So watch out. Although, if I'm going to be subtracting $229.00 from something that ends in a 6, I know that 10 minus 6 is 4, so I'm thinking it's probably going to be this one right here because it's the only one that ends in a 4. I'm going to check it though because that's a lot to gamble at. It's a lot of work I just did. 5 plus 7 plus 9. Okay, let's see. This is going to be 6 plus 10. And this is 11. That's going to be 21. Decimal point. 2 plus nothing plus 6 plus 6. 6 plus 6 is 12. Plus 2 is 14. 4, 5, 6, 11. Okay, $114.16. Do not fall for it. That's how much she has. That's not what the question is asking you. The question is asking you how much more does she need. So, even though I'm pretty much out of space, I'm going to go find some and subtract what she has from what she needs to figure out how much more she needs to earn. I'm going to have to borrow and regroup. 10 minus 6 is 4. Ooh, at this point, I am pretty confident it's going to be H. 9 minus 1 is 8. Ooh, even more confident. Let me just prove it to you. 8 minus 4 is 4. 2 minus 1 is 1. 2 minus 1 is 1. Yep. She needs $114.84 more. Okay, next one. The numbers 1, 33, and 6 were each written on separate sheets of paper and placed inside bag A. Okay, so we got 1, we got 33, we got 6. Then the numbers 24, 5, and 18 were written on separate sheets of paper and placed inside bag B. 24, 5, 18. Okay. If one number is randomly selected from each of the bags, okay, so we got a 1 in 3 chance of pulling each of the numbers here and here. What is the probability that the sum, adding them up, of the two numbers is an even number? Whew, okay. So, let's see. I have a lot to write out. Okay, in the interest of saving a little time, what I did was I picked a number and then I added it to all 3 options from bag. I picked a number from bag A and added it to all 3 numbers from bag B. So here you can see the 1s, then I did the 33s, then I did the 6s, and I'm looking for even numbers. So I have 1 here, 2 options here, 3 options here. Okay, now I'm looking for the probability. So I want the odds of getting what I want, an even number, 1, 2, 3, 4. Out of all the possible options, 1, 2, 3, 4, 5, 6, 7, 8, 9. So my answer is going to be D right there. All right, moving on. Melissa has 3 1/4 jugs of water to share with her volleyball team. Each jug of water holds 144 ounces of water. Melissa is making cups of 6.5 ounces of water. How many full cups can she make for her and her team? Okay, this right here is a word that makes me stop and or a phrase that makes me stop and think. Full cups. So my guess is this is not going to be evenly divisible. We're going to have a remainder, but she's only asking about the full cup, not about the cup that has like a little bit in it. Okay, so what do I need to know? She's got 3 1/4 jugs of water. Each jug holds 144 ounces. So if I multiply them together, I'll know how many total ounces there are. I can't multiply mixed numbers, so I'm going to change this to an improper fraction. 3 times 4 is 12, plus 1 is 13 fourths times 144 over 1. I like to simplify before I multiply, so I can recognize that here this can be divided by 2. 4 divided by 2 is 2. 144 divided by 2 is 72. Ooh, actually they're still even, so I'm going to simplify again. I could have recognized if I knew 144 was a multiple of 4. I could have done that too. 2 divided by 2 is 1. 72 divided by 2 is going to be, 2 goes into 7 3 times, so the remainder of 1. 36 over 1 times 13 over 1. The nice thing about simplifying first is that when I'm done, I know I don't need to simplify my fraction anymore. So now I'm just doing 13 times 36, which is going to be 6 times 3 is 18, 6, 7, placeholder, 9, 3, add them. Okay, 468. Do not write that into your answer. That's only the first part of the problem. I now just know that the 3 1/4 jugs that she had, 1, 2, 3, not that you can actually fill a jug of water like that. Her 3 1/4 jugs are actually 468 ounces. Probably fluid ounces because we're talking about water. She's making cups of 6.5 ounces. So if I want to know how many cups this makes, I'm going to have to split it up into groups of 6.5, which is division. If I can find room for it. I'm actually just going to use the room up here. So I have 468 divided by 6.5. I can also write that as 468 divided by 6.5. Or 468 divided by 6.5. I have a decimal in my divisor. Don't like that. I actually like to get rid of it in the fraction form because I know if I multiply times 10, that'll give me 65, which is a whole number. So I'm actually going to be doing this problem, which is the same if you use the slide. That still gets you 4,680 divided by 65. Ew. Okay. I still like it in fraction form because I'm pretty comfortable simplifying my fractions. I never really learned to simplify them like this. When I see them like this, even though I could, I'm actually going to simplify this before I divide it because we know that simplifying, it'll still give me the same answer. But I just don't really know my multiples of 65 very well. I could list them off to the side. But I can also see, since this ends in a 5 and this ends in a 0, that I could divide them both by 5 and then maybe get down to some friendlier numbers. Okay, 65 divided by 5 is going to be 13. And, oh gosh, what's this? There's a lot of work off to the side in this problem, but it's worth it because we don't even have any options to eliminate. This is a griddable. 5 goes into 4 0 times, goes into 46, 45. Okay, so 5 times 9 is 45. Gives me 1. 5 goes into 18, 5, 10, 15, 20, nope, 3 times. That gives me 3. 5 goes into 30, 6 times. No remainder. Okay, cool. 936 divided by 13. Okay, I guess. But you know what? That's simpler because I can figure out my multiples of 13 a lot easier than my multiples of 900. Whoops, what am I writing? A lot simpler than my multiples of 65. Okay, 13 goes into 9 0 times. 13 goes into 93. Yeah, it definitely does. Let me just figure it out. 13 times 1 is 13. 13 times 2 is 26. 13 times 3 is 39. 13 times 4 is 26 times 2. That's going to be 40, 52. Kind of like the cards, if you're familiar with like the suits of cards, there are 13, red hearts, and there are 52 total cards. That's how I remember the first 4. And then after that, I have to kind of keep adding 13. So 52 plus 13 would be 65. Plus another 13 would be 78. Plus another 13 would be 80, 91. Ooh, that's probably where I'm going to end up. So 1, 2, 3, 4, 5, 6, 7 times, that's 91. The remainder of 2, 26, that's 2 times. Okay, so I got 72. I don't even remember what this problem is about. Let me go back and make sure that sounds reasonable. How many full cups of water? I hypothesized that there might be a remainder. I didn't get one. But, well, I think sometimes words like that are put in to trick us. Sometimes you just like misinterpreted. Full cups? Yep, that's full cups. 72, what I want to be careful with now is when I have a griddable, making sure that 7 goes in the tens place and the 2 goes in the ones place. I don't need to fill in any zeros after the decimal or before or a plus sign. I could if I wanted to, but the most important thing now is to make sure that this matches up in the griddable. Okay. Oh, not yet. Number 19. Look at the diagram below. It represents a 9 by 7 foot board. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yup. 1, 2, 3, 4, 5, 6, 7. Okay, cool. A point is randomly chosen from the board, not just once, but 441 times. Somebody's having a real fun day just randomly choosing points. How many times do you predict the point will be the unshaded area of the board? Okay, well, let's see. I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31 of the total. How many? 7 times 9 is 63. 31 of the 63 parts are unshaded. Okay, so if I pulled a random point, I would expect that 31 out of 63 times it would be unshaded. But I don't want to know about 63 times. I want to know about 441 times. Eek. Okay. Is there any way I could simplify this? Let's see. 3 plus 1 is 4, not divisible by 3. Pretty sure 31 is a prime number, so nope. Nope, that looks like as simplified as it's gonna get. Okay. So I'm working with this one here. How many times, if you did this 441 times, how many times would it be unshaded? Okay, so times 441, make it a fraction. Oh, that does not look fun. You know what I really don't want to do is simplify all that at the very end, because this looks like a really icky problem. You can totally do 441 times 31, get that answer divided by 63. It'll give you your answer down here. I like to try and simplify as I go. You saw me try and simplify this fraction earlier. It didn't work out. But I'm going to look at that 63 and that 441. And I'm going to try and see if I can simplify. My first gut is I always want to try and see if I can divide by 2. But this is odd. This is odd. That's not going to work for me. So I'm going to try and see if I can divide by 3. To check if it's divisible by 3, I use the digital sum. So I'm saying This digit of 6 plus this digit of 3, that's 9. Can I divide 9 divided by 3 into like a whole number? Yes, I can. 4 plus 4 is 8, plus 1 is 9, also divisible by 3. Actually, they're both divisible by 9. So let's try that. 63 divided by 9 is going to be 7. 144 divided by 9, I don't know. I can do it off to the side. Let's see. I know my 9's tables go 9, 18, 27, 36, 45. Nope, so we're going to 36. That's times 4. Gonna subtract. Gotta regroup. 14 minus 6. Well, 6 plus 6 is 12. 13, 14. That's gonna be 8. 9 goes into 81 9 times. Okay, beautiful. So this simplifies when I divided it by 9 to 7. When I divide this by 9, it simplifies to 49. Oh, hey, I know a relationship between 49 and 7. 7 divided by 7 is 1. 49 divided by 7 is 7. So now I'm looking at 31 over 1 times 7 over 1, which is really just 31 times 7. Well, 7 times 3 is 21. 7 times 1 is 7. 217. Ta-da! Moving on to number 20. A married couple decides to file their taxes jointly. That means together. Their joint income for the year is $155,920. Since the couple does not have any kids yet, they are required to pay a 27% annual income tax rate. That kids part is relevant just because when you have kids, they are considered dependent on you, and so your tax bracket and your tax rate can change. But really, for the sake of this problem, it's not important. Okay, how much does the couple have to pay in income taxes for the year? Ooh, okay, some icky numbers. I have a strategy for this, though, because I really don't want to solve this problem. That seems like a really long multiplication problem. If you want to do it that way, go right ahead. You're going to get the right answer. But I'm going to use my benchmark percents to try and make this easier on myself. So I have $155,920. I'm trying to find 27% of that. 27% is pretty close to 30%. I know I can find 30% by finding 3 groups of 10%. So to find 10%, find my decimal point, and I say, well, let's see, it's going to move once because I'm really like dividing this by 10, because 100% divided by 10 would give you 10%. Okay, so 10% of this, okay, now that's 15,000. Okay, so if that's 10%, then I'm going to multiply that 3 times. That's going to give me 6. 9 times 3 is 27. 15 plus 2 is 17. 15 plus 1 is 16. Okay. So 30% is $46,776. I'm actually looking for 27%, which is less than that. So this cannot be my answer because that's more than that. This cannot be my answer because that's more than the 30%, and I want less than that. Okay, how much less than that, though? Well, I have 30%. I'm trying to get to 27%. That is 3% less. I know that I can go find 3% of my original amount by saying, oop, there's 1%. Because if I took the whole 100% amount and I divided it by 100, that would give me 1%. Dividing by 100 is like moving it to place values to the left. So 1% is this much. Times 3. Oh, it's probably going to be something like this because this was times 3 as well. It's actually going to wind up being the same digits, but one place value over. Okay, so 1% is $4,677.60. I'm going to, oh sorry, that's 3%. if I subtract this minus this, it'll give me my answer. So, I can actually find my answer just based on this right here. If I regroup, I have, oops, I didn't need that. 0, 10 minus 6 is 4. Oh, this one is not 40 cents. This has to be my answer. Which makes sense because it's like 46,000 minus 4,000. It's going to give you somewhere around 42,000. So there's our answer.